Azure Machine Learning, Azure ML, is a cloud-based service that provides a comprehensive suite of tools for building, training, and deploying machine learning models. The Azure ML workspace is the foundational resource in Azure ML, acting as a centralized place to manage all the artifacts and resources needed for machine learning. This includes datasets, experiments, models, and compute resources. Understanding how to manage an Azure ML workspace is crucial for efficiently designing and preparing machine learning solutions. To create an Azure ML workspace, you need an Azure subscription. Navigate to the Azure portal, select Create a Resource, and search for Machine Learning. Follow the prompts to configure the workspace, including specifying the resource group, workspace name, and region. Once created, the workspace will serve as the central hub for all your machine learning activities, providing access to various tools and resources. An Azure ML workspace comprises several key components: datasets, experiments, pipelines, models, and endpoints. Datasets are collections of data used for training models. Experiments track the runs of your machine learning tasks. Pipelines automate workflows, models store trained algorithms, and endpoints manage deployment. Each component plays a vital role in the machine learning lifecycle, from data ingestion to model deployment. Datasets in Azure ML can be registered, versioned, and shared across multiple experiments. You can upload datasets directly through the Azure portal or use the Azure ML SDK for more advanced operations. Proper dataset management ensures reproducibility and consistency in your experiments. Additionally, Azure ML supports various data formats and sources, including CSV files, SQL databases, and Azure Blob storage. Experiments in Azure ML are used to organize and track the runs of your machine learning tasks. Each run can log metrics, parameters, and outputs, providing a detailed record of the model training process. This tracking is essential for comparing different models and selecting the best performing one. The Azure ML SDK and the Azure portal offer tools to visualize and analyze experiment results, making it easier to iterate and improve your models. Pipelines in Azure ML allow you to automate and orchestrate complex machine learning workflows. A pipeline can include multiple steps, such as data preprocessing, model training, and evaluation. By using pipelines, you can ensure that each step is executed in the correct order and that the entire workflow is reproducible. Azure ML provides a visual interface for building pipelines, as well as an SDK for programmatic control. Model management in Azure ML involves registering, versioning, and deploying machine learning models. Once a model is trained, it can be registered in the workspace, making it available for deployment. Versioning allows you to keep track of different iterations of the model, ensuring that you can always revert to a previous version if needed. Azure ML also provides tools for monitoring model performance and retraining models as necessary. Deploying models in Azure ML can be done through various endpoints, such as Azure Kubernetes Service, AKS, or Azure Container Instances, ACI. These endpoints provide scalable and reliable environments for serving your models. The deployment process involves packaging the model, creating an inference configuration, and specifying the deployment target. Azure ML handles the underlying infrastructure, allowing you to focus on the model itself. Compute resources in Azure ML are essential for running experiments, training models, and deploying endpoints. Azure ML supports various compute targets, including local machines, Azure VMs, and specialized hardware like GPUs. You can configure and manage these resources through the Azure portal or the SDK. Proper management of compute resources ensures that you have the necessary power to handle your machine learning tasks efficiently. Security and compliance are critical aspects of managing an Azure ML workspace. Azure ML provides several features to ensure data protection, including role-based access control, RBAC, virtual networks, and encryption. Compliance with industry standards and regulations is also supported, making it easier to meet legal and organizational requirements. Understanding these features helps you maintain a secure and compliant machine learning environment. Azure ML facilitates collaboration by allowing multiple users to work within the same workspace. You can share datasets, experiments, and models with team members, enabling seamless collaboration. Role-based access control, RBAC, ensures that each user has the appropriate permissions, enhancing both security and productivity. Collaboration features are particularly useful in large projects where multiple data scientists and engineers need to work together. Monitoring and maintenance are ongoing tasks in managing an Azure ML workspace. Azure ML provides tools for tracking the performance of deployed models, including metrics and logs. Regular monitoring helps you identify and address issues promptly, ensuring that your models continue to perform well. Maintenance tasks may include updating datasets, retraining models, and scaling compute resources. Effective monitoring and maintenance are key to the long-term success of your machine learning projects. Cost management is an important aspect of managing an Azure ML workspace. Azure ML provides various tools and features to help you monitor and control costs, including budgeting, cost analysis, and resource tagging. By understanding and utilizing these tools, you can optimize your spending and ensure that your machine learning projects remain within budget. Effective cost management involves regularly reviewing your resource usage and making adjustments as needed. To effectively manage an Azure ML workspace, it's important to follow best practices and tips. These include organizing your workspace components logically, using version control for datasets and models, automating workflows with pipelines, and regularly monitoring performance. Additionally, leveraging Azure ML's security features and cost management tools can help you maintain a secure and cost-effective environment. By adhering to these best practices, you can maximize the efficiency and effectiveness of your machine learning projects. Managing an Azure ML workspace is a multifaceted task that involves creating and organizing resources, tracking experiments, building pipelines, managing models, and ensuring security and compliance. By understanding and utilizing the various features and tools provided by Azure ML, you can streamline your machine learning workflows and achieve better results. The next steps involve applying these concepts to your own projects, continuously learning, and staying updated with the latest Azure ML features and best practices.